Welcome to Homework Lib.
Hi, so in this question we want to find the pH of a solution that is formed by mixing 100 milliliters of 0.1 molar sodium fluoride with 100 milliliters of a 0.02 molar solution of hydrochloric acid. Information that is given to us is that the Ka for HF is equal to 7.24 times 10 to the minus 4. First of all, the pKa, remember that this is the minus logarithm of Ka, is going to be equal to 3.14, and this is going to become useful in the case that we end up with a buffer solution, right? Okay, so first of all, we need to identify what is going to actually happen in our reaction and what is going to be the final products. So we're going to have the mixture of sodium fluoride with hydrochloric acid. Remember that both of them are going to dissociate in solution in order to produce, respectively, for the first one, sodium plus F minus, and the case for hydrochloric acid, we're going to generate in the presence of water the hydronium ion plus Cl minus as an ion. So the actual species that are going to react are the hydronium ion with F minus, and we know that the quantities correspond to the same amount of mole that we have on each of them. So if we want to calculate the concentration of F minus, this is going to be equal to the concentration of NaF. And the same thing happens with the concentration of hydronium ion. Since this is a strong acid, this is going to be the same as the concentration of HCl that we initially added to our solution. So, first step, we need to identify what is going to be the total volume that we're going to have. The total volume is going to be equal to 200 milliliters, or expressed directly as 0.2 liters. Next thing that we need to identify is the amount of mole of F minus that we're going to have present in solution. Remember that the definition for molarity is amount of mole divided by the volume in liters. So if I added 100 milliliters of the sodium fluoride solution, the amount of F minus that is going to be generated, it is going to be equal to the volume times the molarity. So the volume added was 0.1 liters, 100 milliliters, times the molarity of sodium fluoride, that is 0.1 molar. Remember that molar is mole per liter. So 0.1 times 0.1 is nothing but 0.01. And this is the amount of mole that we have of F minus. Now the amount of mole of H2O plus that we're going to have present in this solution is going to be the same formula. The amount of volume is the same thing. Next up, the concentration is where things change a little bit. So in this case, we're going to have 0.02 mole per liter. As you can see, this is nothing but 1/5 of the amount that I have of F minus. So this is going to be 2 times 10 to the minus 3 mole. With this, we can proceed and generate our ice table. We're going to have the reaction of F minus plus H2O plus. We're going to do this in terms of mole, and then we're going to verify what happens at the very end. And this is going to generate HF plus water. Initially, of F minus, I'm going to have 0.01, 0.01. Of H2O plus, I have 2 times 10 to the minus 3, so 0.002. Of HF, I have nothing, and water, it is not going to matter because that is a condensed phase, and it doesn't enter into any equilibrium constant. So, as you can see clearly here, the limiting reagent is H2O plus, the hydronium ion, and at equilibrium, we're going to end up with something close to 0. 0.01 minus 0.002, this is 0.008. And of HF, I'm going to have 0.002. And all of this is going to be in mole and mole. In this case, we're going to have a buffer because we have an acid with its conjugate base present in solution. And in order to calculate the pH of a buffer solution, recall that pH is equal to pKa plus the logarithm of the concentration of the conjugate base. In this case, it's going to be the concentration of F minus divided by the concentration of the weak acid that we are dealing. An extra step here, we can go directly and do the calculation using the amount of mole because the volumes are going to cancel in this equation. To verify this, you can go ahead and substitute the concentrations by the amount of mole divided by the total volume. And as you can see, these terms are going to cancel out. So in our case, our pH is going to be equal to the pKa that we said that was 3.14 over here. 3.14 plus the logarithm. Instead of concentration of F minus, I'm going to write down the amount of mole of F minus. So this is 0.008 divided by the amount of mole of HF, that is 0.002. The result for this is 3.74. And this is going to be our final answer. Thank you very much. That would be all.